So this is about complex complex roots of polynomial functions. I better look at my notes because I have some notes here. So what this says is that every complex polynomial function f of x of degree n greater than or equal to 1 has at least one complex zero. So if it's like x squared, how many zeros does it have to have? It's going to have 2, okay? So right here it says, in other words, a degree n polynomial has exactly n factors, some of which may be complex and or have higher degrees than 1. Not that one, than 1. So what that means is that you have as many roots or factors as you do the degree of the equation, but many of them may be imaginary. When they talk about complex, a complex number is a number like of the form. This is my pen. A complex number is a number of the form 3 is a complex number. Did you know that? But so is I. Because complex numbers take the form a plus bi. Okay? And a is called the real part, and this would be called the imaginary part. Okay? Imaginary, you guys are kind of familiar with imaginary numbers, right? Yes? I, what's I? Square root of -1. Okay? And so 3 is a complex number, I is a complex number, 2 minus 3i would be a complex number. All of those are complex numbers. This is an imaginary complex number, as is this. This is a real complex number where the I part would just be plus 0i. Okay? So this one represents a root where it actually crosses the x-axis, whereas when you have imaginary roots or solutions, then your graph won't cross the x-axis, but you still have imaginary roots or complex roots, whatever you want to call it. Okay? So every complex polynomial f of x of degree can be factored into linear factors, not necessarily distinct. What that means is that some of them may be squared. Okay, so you could have x minus 2 squared counts as 2 factors. Okay, so you could have an x minus r1 squared, but altogether those are going to add up to the degree of the polynomial. You know, so if you have like something like x cubed minus 3x squared plus 2x. How many factors is that going to have? 3. And some of them may be real, and some of them may be complex, but at the minimum, you're going to have 3. Okay? Corollary. A polynomial of odd degree with real coefficients has at least one real zero, because if it's odd, okay, if the function is odd, it's either going to start down here and work its way up, or it's going to start up here and work its way down. How many times must it cross the x-axis? At least. It has to at least cross the x-axis once, right? If it's starting up here and it ends down, at some point it's got to be going through. So if it's odd degree, it has to have at least one real zero. If it's even degree, does it have to have a real zero? Hello? If it's even? No, because if you have an even degree function, it could look like a W, like that, could be pushed up. So you could have even degree functions that have all complex roots or zero. Conjugate pairs theorem says, Davis, conjugate pairs theorem says, if r equals a plus bi is 0, then so is a minus 2i. So a lot of times they'll say like 2 minus 3i is a complex 0. What has to go with that? What else has to be a complex 0? 2 plus 3i. Those always come in pairs. Okay? And same for if you just have like a negative 7i, what would have to go with negative 7i? It's plus 7i. Okay? And so know that. Find the complex zeros of the function. So this is how you do this. You ready? First you take a picture of it with your camera. I have a camera. Right here. What? No. What happened? I just took a picture of it, but it didn't go. Partial. Place capture new page. Oh, that's what it is. So here we go. And there it is. So if you have this one, x squared minus 4x plus 13, you could try to factor that. Does that factor? No. So what do you have to do if it doesn't factor? Quadratic formula. Very good. So so I'm going to do the quadratic formula on this, and I get x equals negative 4, right? Which is plus 4, plus or minus the square root of minus 4 squared, which is 16, right? Minus 4 times a, which is 1, times c, which is 13. The whole thing divided by 2a. 2a, which is 2 times 1, right? Which is just 2. So then you simplify that, and that is 4 plus or minus the square root of, how much is that? 26, 52, 16 minus 52. Is that right? Or 16 minus, is that 36? Negative 36? Would you agree with me there?
Can you just write 2 plus or minus negative 36 over 2?
No, you can't just write 2 plus or minus, because you have to divide this as well. Okay? Oh, you could put the 2 out here.
Yeah.
But then let's wait till the end. Okay? So this is equal. Do you guys remember how to simplify this thing in the square root? What could I take out of here?
6.
6, right? So this is the same as the square root of 36 times the square root of negative 1, which is what? I, right? Over 2. You don't have to do all these steps. I'm just trying to do it for clarification. So this is 4 plus or minus 6i over 2. And now, Kim, you can divide everything by 2. So you get, that's equal to 2 plus or minus 3i. So in other words, one root is 2 plus 3i, and one root is 2 minus 3i. Yeah? You've done this before. Have you done this? So those are the complex zeros. So if you see something like this, like a 4th degree, where it says find all the zeros, what they want you to do is first, in the book, they kind of want you to find all the possible p's and q's here. So this is a lot, right? Because you have plus or minus, the p's give you plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. And the q's, the factors of this, are plus or minus 1, plus or minus 3. Yes? So the p's over the q's are plus or minus 1, plus or minus 1/3, right? Plus or minus 2, plus or minus 2/3, plus or minus 3, plus or minus 3 over 3, which is 1, which we already have, plus or minus 6, 6 over 3 we already have, plus or minus 9. 9 over 3 we already have. Plus or minus 18. Plus or minus 18 over 3, which is 6, which we already have. So do you understand where I get those from? Good? Okay, so then you have to do synthetic division on every single one of these, which is a huge headache, right? You take up a piece of paper using one problem. So what I will usually let you do, or the book will do, and on a test if you had a 4th degree one, or even some 3rd degree ones, I'll say use your calculator to find the first root, okay? So I'm just going to tell you that in this case, you have, if you graph this on your calculator, you would see you have one root is -2, okay? And so I would either give you that or tell you, you go ahead and use your graphing calculator. Then you go like this, 3, 5, what's that, 25, 45, and -18, and you do your synthetic division here. And you bring this down. And so 3 goes there, -6 goes here, -1, +2, 27. 27 times 2 is -54. Add those together, you get -9. And -2 times -9 gives you nicely +18. So you get 0, right? Yes? Sure. Okay, so then you have that this thing so far, it factors to x what? +2 times 3x to the 4th minus x to the 3rd plus 20. All right. Oh, we started with 4th degree. I'm sorry. Okay, I was confused. We started with 4th degree, so this is going to be 3rd degree x squared 227x minus 9. Okay? Now you could try to do synthetic division again. Okay? But I'm not. Oh, I did do that. I say use 1/3. So can I do a. I'm trying to see if I could do factor by grouping. Okay? So looking at these first two terms, what could I pull out of both a 3x squared and an x squared? X squared. So what I'm going to do is rewrite this as as x squared times 3x minus 1 plus 9 times x 3x minus 1, right? And it's kind of like this, which I can rewrite now as x plus 2 times x squared plus 9 times 3x minus 1. You guys understand that?
Yeah.
Okay, I did factor by grouping. So now, this thing, we already have this factor, or this root, x equals -2. This gives you 3x equals what? Or x equals what? X equals positive 1/3, which was one of my possible rational roots. And this gives my other two imaginaries. What are those two? Oh, who said that? You're so smart, okay? So x squared equals -9. So x equals plus or minus the square root of -9, or x equals plus or minus 3i. So a 4th degree equation, you have 4 roots, 2 of which are real and 2 of which are imaginary or complex. Yes? Well, so altogether you're going to have 4 roots and boys. So write a 5th degree polynomial with real coefficients and roots. So if a function has imaginary roots or complex zeros, it doesn't, the function has real coefficients, okay? So we can write, even though it has imaginary roots, it has real coefficients. One thing I didn't talk about is that this thing, if you have a 3 minus root of 7, you also have a 3 what? Plus root of 7, okay? So if you have a radical number like that, then you also have a 3 plus root of 7. So what this means is if this is a root, if negative 2 is a root, what is the factor? X plus 2. If 2 plus I is a root, what else has to be a root? 2 minus I, okay? And if 3 minus root of 7 is a root, what else has to be 3 plus root of 7? So what I have to do now, that's a 7 right there. It looks like an 8, doesn't it? Okay, so now it's a 7. So what I have to do is write this as x plus 2 times x minus, in parentheses, 3 minus root of 7 times x minus, I need another parenthesis there, x minus 3 plus root of 7 times x, I'm going to write up here, it's easier for me, x minus 2 minus I, like that, and x minus 2 plus I, like that. And now all I have to do is multiply all that together. Can you do that? So let's do a little, it's kind of complicated. It's kind of complex. Okay, so x plus 2 we have here. And then I'm just going to look at one piece at a time. If I FOIL this, okay, so let's look at this. We have x plus 2. This thing, when I FOIL it, I go x times x. That gives you x squared. Then I have, so here we go. Then I have minus, first outer gives you minus x times 3 plus root of 7. See what I did? That's this times this. Minus 3 plus root of 7 times x. That's the 2 outer terms. The 2 inner terms give you minus x times what? 3 minus root of 7, right? See where I got that from? And the 2 last terms are this times this, which is plus 3 minus root of 7 times 3 plus root of 7. Yes? See what I did? Okay? So I'm not even going to worry about this imaginary part yet. Okay? Then what I get is I have x plus 2. There's still this part over here to worry about, but we're not going to worry about that yet. I have times x squared. I have minus 3 times x and minus 3 times x. So how many minus x's do I have? 6x. I have a minus x root 7, and I have a minus times a minus x root 7, which is what? Those ones disappear. See that? This negative x times root of 7 and negative x times negative root of 7 disappear. And then I have to FOIL this. Well, foiling this gives me 9. This 3 times negative root of 7 and 3 times positive root of 7 disappear. And what's negative root of 7 times positive root of 7? Negative 7, right? Makes the square roots disappear. So this mess, this multiplied by this, gives me x plus 2 times x squared minus 6x plus 2. So far, so good? Okay. Then I FOIL this part. Aye. Okay. And when I FOIL that part, I better make my parentheses bigger. So when I FOIL this part, my first term gives me x squared. My next part, I just want to show you how this works. Minus x times 2 plus I, right? Right? X times negative 2 plus I. Then the two inner terms give you minus x times 2 minus I. And then I have to plus, I have to FOIL this thing here, plus this times this, which is 2 minus I times 2 plus I, right? 2 minus I times 2 plus I. And when I multiply this mess out, I get x squared minus 2x and minus 2x. I do have a minus 4x there. Minus xi and plus xi disappears. See that? Negative x times I and negative x times negative I, that disappears. And then I go over here. 2 times 2 is 4. Negative 2i and plus 2i cancel out. And then I have minus I squared. What's minus I squared? Positive 1. I squared is negative 1. So I squared, negative I squared gives you positive 1. So when I multiply all that out, was this a 4 or a 4x? No, that's a 4. I get x squared minus 4x plus 5. Okay? And then I have to multiply that, x plus 2 times x squared minus 6x plus 2. And then you keep multiplying, which is a pain in the neck. Okay? But if you multiply all this together and then you multiply all this together, you come up with your polynomial. I'm not going to do it. Okay? And your polynomial ends up being x to the 5th plus 2x to the 4th plus 7x cubed plus 14x squared minus 10x plus 20. Okay? So I don't think I'm going to make you multiply that all out on a test. I think I've given it in the past. You can make up